This video will cover the creation of a tank foundation with STAAD Foundation Advanced. On the opening screen, click Plant Mode and then Create Tank Foundation. A wizard will pop up with a sequence of steps to create the foundation design. The user can skip to any step using the navigator on the left or go in order. The first window, called Tank Foundation, is only to specify basic information pertaining to the tank foundation job. A tank ID or title is required. The ID allows for differentiation between multiple tank foundation jobs in the same file. Unit system and design code can be changed with these options. The user can also choose to do sliding or overturning checks and specify the angle in degrees between drawing north and true north. Weight input provides two options for the program to calculate the fluid's weight in the tank. Both options change inputs in the primary load cases section. The first, direct weight input, allows the user to input operating and test fluid weight and height for the program to calculate appropriate weight values. The second, tank fluid volume input, gives fluid properties like operating product volume, test product volume, and specific gravity of the product to calculate weight. Tank geometry provides inputs for the geometry of the tank foundation. Bottom of footing elevation will be used for the detailed drawing only to show elevations of different levels. A width increment value may be changed, which will be used to increase the width if necessary. The depth increment may not be changed. Ring wall geometry options like eccentricity from tank diameter to footing centerline, width, and height options can be inputted. Width has a minimum and maximum option to allow the program to calculate the most efficient design within a specified region. Also, concrete slab thickness, compact granular fill, and miscellaneous weight for attachments options are available. The diagram shown here gives reference to the tank foundation geometry values. Tank and fluid properties provides tank geometry, thickness, and material property inputs. The tank pictured here provides reference to tank geometry and thickness inputs. The tank material properties are yield strength of bottom plate, elastic modulus of tank shell, and tank material density. These inputs are used to calculate the empty weight of the tank. Most of the loading section was explained earlier when selecting between direct weight input and tank fluid volume input. This applies to all sections, but it's important to make sure that all of the units are specified correctly. Keep in mind that two pressure unit inputs are given, one for internal pressure and one for pressure load. Operating and test level internal pressure must be inputted. Potential pressure loads include roof snow load, miscellaneous dead load, and live load. A snow importance factor is also provided. In wind load generation, the user has the option between user-defined wind load and calculated wind load. The program calculated wind load option will calculate the shear and moment value based on the given input values. A few of the values are taken from tables in ASCE 705, which are shown if you click on the buttons. Tables 6.6, 6.1, and 6.21 are provided to determine KD, I, and CF, respectively. A description of each of the inputs is given in the blue box. If the shear and moment values are already known, selecting user-defined wind load will allow for their direct input. STAAD Foundation Advanced requires the convective seismic loads and impulsive seismic forces for both operating and test shear and moment for tank design. These values are inputted or calculated in the seismic load generation section. If they are known, select Directly Input Seismic Load to enter the values. If not, other parameters become available which will generate these values for you. Also, the user can choose to enter seismic ground motion values manually or select using zip code. The seismic parameters, seismic use group, damping adjustment factor, and long period transition period can be adjusted as well. STAAD Foundation Advanced calculates seismic loads based on API 650 for both US and Indian code. In the load combination section, service and ultimate load combination tables are shown similar to the load combination tables in the general mode under loads and factors. Here the user can choose to use either ASCE 705, PIP, or user-defined to enter his or her own load combination values. If ASE 705 or PIP design code is selected, the values in the table can still be edited. The design parameters are split into soil properties, material densities, safety ratios, and concrete and reinforcement. Soil properties include allowable soil bearing pressure and the coefficient of friction. The safety ratios include sliding safety ratio, soil bearing multiplication factor, lateral earth pressure coefficient, and overturning safety ratio. Concrete and reinforcement contains basic related information. Stirrup and bar sizes will be designed most efficiently between the user specified minimum and maximum values. After all of the steps have been completed, click Finish. This example says Edit because I switched to an existing example file to show standard values. The tank and foundation can now be viewed in the geometry view. This is a graphical representation of the user's input with a typical tank. From this point, you can either edit, which takes you back to the tank creation wizard to edit any section, or you can delete or design. You can also input any number of plant foundations in the same file. Designing creates a calculation sheet and detailed drawing. Calculation sheet specifies how each footing was designed. It includes detailed steps, figures, and references to the code which was used for design. STAAD Foundation Advanced uses ASCE 7 or IS 875 Part 3 for wind load generation, API 650 for seismic load generation, API 650 Appendix E for serviceability checks, API 650 PIP STE 03020, and ACI 318 or IS 456 for concrete design. Let's take a closer look at the tank stability design calculations in the calculation sheet. Here, design steps are shown, including the required equations and user inputs. Detailed drawing gives plan, elevation, and section views of the footings. This drawing shows tank dimensions and any reinforcement. Thank you for watching the tutorial.